Hi, today I want to explain about qualitative analysis in organic compound. So, when a substrate react with the reagent, it gives the product along with maybe byproduct. So, this formed product first purified. After purification, we have to check quality, then we have to go for quantity. So now I am explaining about the quality. What elements are present in a prepared organic compound? So first I am using the detection of carbon and hydrogen. So taking organic compound, it is contain carbon and hydrogen heated with the copper oxide. On heating, if carbon is present, it gives a carbon dioxide. Hydrogen present, it gives the water molecule, and copper comes out. This is a equation. Now I will write the individual equations for carbon. So for carbon, organic compound containing carbon plus copper oxide. On heating, this will give the carbon dioxide plus copper. 2 oxygen, therefore 2, then 2 copper. Now this liberated carbon dioxide is colorless. Therefore, to identify this colorless gas, pass this carbon dioxide gas into the calcium hydroxide solution. This is called milk of lime. Then it gives a turbidity of calcium carbonate plus water molecule. I think 2 oxygen balance this is. Then it gives a turbidity or precipitate. We call this is precipitate or turbidity. So calcium carbonate turbidity formed meaning we can confirm that carbon present in the organic compound. This is confirmed. Next, now hydrogen related. Organic compound containing hydrogen heated with the copper oxide, then it gives a copper plus water. It is a balancer because hydrogen many are present, so like this we cannot balance, only copper related I am writing. So now this is also colorless water molecule. Then this water molecule treated with the copper sulfate. This is generally colorless, mean we call white. Then when it react with the water molecule, it form copper sulfate 5H2O. Then here 5. This is generally blue color. So blue color formed meaning we have to understand this is a hydrogen present. Hydrogen present. Okay. So this is about the detection of carbon and hydrogen. Next one, last sign test. This last sign test for detection of nitrogen, sulfur, halogen. Halogens are chlorine, bromine, iodine, and finally phosphorus. So these elements can be identified by using Lassen test. How to do this Lassen test? Organic compound containing in any one element, and this is heated with the sodium metal. After heating, use the distilled water. So add into this distilled water, then boil this water up to half volume, up to half volume. Then filter it. That filter rate is known as a sodium fusion extraction. SFE mean what is it? Sodium fusion extraction. This sodium fusion extraction, sodium plus carbon plus nitrogen, it forms sodium cyanide. Sodium fusion extraction. Sodium plus sulfur, it gives a sodium sulfide. Next is sodium plus halogen, it gives a sodium halide. Sodium plus carbon plus nitrogen plus sulfur, it gives a sodium thiocyanate. These are the sodium fusion extraction. By using this sodium fusion extraction, we can identify the different elements. So the first one, according to Lassen test, I am identifying the nitrogen. So according to this one, first, according to textbook, I will write this is a sodium fusion extraction is used here NaCN. Then this is Cn minus cyanide, in this plus, this is minus 1, only half reaction I am writing. Then this cyanide react with the ferrous sulfate in that Fe plus 2An. These two combine to form FeCN taken 6 whole power. This will give the minus 4. Okay. Then this is called hexacyanidoferrate 2 ion. Then this is the first step. Then second step, ferric what do you call ferrous ion Fe2 in presence of concentrated sulfuric acid. Then this will be converted into Fe plus 3 and electron. This is called oxidation, oxidized this is. Then third step, this Fe plus 3 ion react with the hexacyanidoferrate. So these are cross multiplied. This will become here, this will become here, and the product formed is FeCN6, and this cross multiplied mean here 3, here 4. So common name of this one is called, this is a ferrocyanide. IUPAC name is iron 3, hexa cyanido ferrate 2. This is generally Prussian blue color. Which color this is? Prussian, sorry, spelling wrong. Prussian blue color. So Prussian blue color appear mean nitrogen present in the organic compound. So nitrogen present. Next, sulfur. Detection of sulfur. Take the sodium fusion extraction. Sodium fusion extraction for this Na2S. So here half reaction. So first one, this sodium sulfide or sulfide, it reacted with a lead acetate. In that half reaction I am writing in Pb plus to taking. Then it gives a PbS and a black PPT form. Black precipitate form. Black precipitate meaning this confirm the sulfur present in the organic compound. One. Otherwise, another B also is there. B reaction is this sulfide react with the sodium nitroprusside. So that is represented as the FeCN5NO. So this is sodium is not writing in here, it is a -2 form. Nitroprusside we can write. IN. Then this will be converted into FeCN5NOS. Then this is converted into -4. Then this is a violet color solution form. Then it confirms that sulfur present in the organic compound. In case both sulfur and nitrogens are present, that time nitrogen and sulfur detection together. If nitrogen and sulfur both are present, then that time sodium fusion extraction is NaSCN. In this half reaction, SCN, sodium thiocyanate, react with the neutral FeCl3, but here they are written as a ionic form Fe plus 3. Then it convert into FeSCN taken twice and here plus 2. Then this is called a blood red color. Which color is a blood red color form, artificial blood. This indicates that both nitrogen and sulfur are present in the organic compound. But here note, what is a note? Na2SCN. For this, if you use excess of sodium, then what will form? It will form NaCN and Na2S. They will give their individual test. That's why carefully use the sodium. Excess used means they will form different one. That's why limited according to requirement only we have to use. Next, detection of halogen. Halogen means chlorine, bromine, iodine. So now it's NaX is a sodium fusion extraction. So I am taking here X minus. This is treated with the first concentrated HNO3. Why it is used later I will tell. And later use the AgNO3 aqueous. Then it form AgX. In this AgX, it may be AgCl. This is a white PPT. Then add ammonium hydroxide. Then it gives a soluble, which one? AgCl soluble in ammonium hydroxide. So AgCl soluble in NH4OH. Then in case AgBr, this is a pale yellow PPT form. Then add ammonium hydroxide. Then AgBr sparingly soluble, it means little soluble in ammonium hydroxide. And then the final one, AgI. This is a yellow PPT. This yellow PPT, when you add ammonium hydroxide, AgI insoluble in ammonium hydroxide. So these confirm that chlorine present here, bromine present, this is iodine present. Then detection of phosphorus. Now organic compound containing phosphorus treated with the sodium peroxide, then this will be converted into Na3PO4. This is called sodium phosphate. Then this Na3PO4 treated with the HNO3. This is converted into H3PO4 plus NaNO3. Then here 3 times, then it balance. Okay. Then this phosphoric acid H3PO4 treated with the ammonium molybdate. These are 12 times, and here 21 HNO3. Then this will be converted into ammonium phosphate. Then this ammonium phosphomolybdate 12MOO4 plus it gives a 21 NH4NO3 plus 12H2O. This compound is yellow coloration or yellow PPT or yellow PPT. That indicates here phosphorus present in the organic compound. Next, the final one, Oxygen. No separate test for oxygen. Functional group test is oxygen test. Example: alcohol test, functional group test; aldehyde group, functional group test; keto group, functional group test; carboxylic acid also functional group test. Like this, anyone having oxygen, that functional group test, if you perform, they gives the oxygen present in the organic compound. So these are the identification tests for given element in the organic compound.